Find the critical Z alpha divided by 2 value for a 99% confidence interval designed to estimate the population mean. All right, so if you're trying to solve this problem, when you're looking for a critical value, what you need to remember is that you need to look for the confidence level in the problem. And then from there, you're going to say, okay, look, if the confidence level is 99%, what is alpha? Well, alpha and the confidence level have to add up to 100%. So it must be true that alpha is 1%. So in other words, all I did was do 100% minus the confidence level, and that will give me alpha. Now, alpha written as a decimal here would be 0.01. Now, if we know that, then we should be able to figure out the notation here. If it says Z alpha divided by 2, this is the same as saying Z, our alpha is 0.01. If we divide that by 2, we'll end up getting Z 0.005. That's what happens when you divide 0.01 by 2. Then you can go to a t-table and look up this alpha value in one tail. All right, so let's go see where we can find that quantity. Okay, here we are looking at a t-table, and you can see the area in one tail. They have that first number, 0.005, which is the exact number we're looking for, right? Now, if we go down in the table, if we scroll down, all the way to the bottom on a t-table, you have some z-score values, and they're at the very last row of the table. So if we go all the way down, way down to the bottom, you see that we get the answer 2.576. You can see my table is labeled here with a Z. Now, you'll also notice my table can be used even faster than what we just did because we have 99% confidence listed at the bottom, and that's the confidence level we were looking for. So we could have just come here and said, oh, the z-score associated with that confidence level is 2.576. Not all tables here used at FIU have this bottom row labeled with the confidence level. So if you don't have a t-table that's labeled in that way, you just have to remember to do it the way we did it, which is to say, okay, take alpha, divide it in half, and look that up at the top of your t-table. And that'll be the area in one tail, or in other words, alpha divided by 2. So that 0.005 value that we came up with. And then we go all the way to the bottom where the z-scores are located, since we need a critical z value, and we find the number 2.576. Okay, so in the end here, we can say that z 0.005 is equal to 2.576, which is the critical z-score that we need when constructing a 99% confidence interval. Okay, so now that we have that, let's look at this second example. It says find the critical z alpha divided by 2 value for a 96% confidence interval designed to estimate the population mean. So if you wanted to know what alpha divided by 2 is here, it would be 4%, right? Because 4% and 96% add up to 100%. And then alpha divided by 2 would simply be 2%, written as a decimal 0.02. And if you went to your t-table and tried to look that up, you would find that it's not there. So at the top, you see we don't have 2%, right? We have 2.5% and we have 1%, but we don't have 2%. This means the t-table cannot be used here. Also, if you're using the bottom row in my class, you see there's no 96%. There's a 98 and 95, but there's no 96. 96 is not a very commonly used value, and that's why it's not on this table. But we could use the z-table to find this. So let's see how that would be done. When this fails, when this procedure doesn't work, it means the t-table is not going to help you here. So we're just going to start over, basically. And when that fails to work, when the t-table fails to work, all we do is we take the confidence level, which is 0.96 as a decimal. So you want to express it as a decimal, then just divide it in half, divide it by 2. So I do 0.96 divided by 2. I get the answer 0.4800. And then I'll look this up, and I'll look it up on my z-chart to find the corresponding z-score that's associated with it, right? So we're going to say to look up the confidence level divided by 2 on the z-chart, right? And that will solve the problem for us. It'll give us the critical value we need, at least to 2 decimal places, right? All right, so let's go look up 0.4800. All right, so here we are on our z-chart. Let's look up 0.4800 if we can. So I'll go down in this first column here in the probability part of the table, right? To try to find 4,800. So I see that there's a 0.4772 here. Let's go over in this row and see what we get. So this is pretty close, right? But it's not as close as this number here. This number is actually the closest number. All right, and if you count over from that position, you'll see that that's 2.05. Scrolling way to the top, you see it's 0.05 in that column. And of course, it's 2.0 in the front two digits, so 2.05. So our critical z-score, our z alpha divided by 2 value, is 2.05. If you wanted to fill in the notation here, alpha divided by 2, remember that our alpha was 4% or 0.04. And if we divide that by 2, alpha divided by 2 is 0.02. So if you wanted to fill in the notation, you could say z.02 is equal to 2.05. Filling in the notation here is not necessary. What we really care about is this value, 2.05. That's the number we're looking for, and that's the solution to the problem.